plus bx plus c. Vertex form is the form we've been focusing on. It's a quantity x minus h squared plus k. So what we want to do today is kind of go back and forth between our two forms. So it says, what would the graph of y equals x squared plus 2x plus 3 look like? So now we are in standard form, and we want to get a graph, but in order to be able to do that, we want to convert from standard form to vertex form. So I need to know what is A, what is B, and what is C. So the A value is always on x squared, the B value is always on x, and the C value is always your constant. So A goes with quadratic, B goes with linear, C goes with quadratic. There is a specific equation for the axis of symmetry. There is a specific equation for the axis of symmetry. That equation is the opposite of B divided by 2A. That should look like the beginning of the quadratic formula because it is. That should look like the beginning of the quadratic formula because it is. So the quadratic formula gives you your roots. Your roots are symmetric from the vertex. So the vertex, or the axis of symmetry, is negative b divided by 2a. That's equal to h in my other form. That would be equal to h in my other form. In terms of this particular problem, this would be equal to negative 2 over 2 times 1. So negative 2 divided by 2 is negative 1. So what that means is this graph is going to have a point at negative 1 and be symmetric around negative 1. To find k, we plug in h to the original equation. So you have negative 1 squared plus 2 times negative 1 plus 3. So k is equal to 2. So that means that my vertex is at negative 1, positive 2. My a value is 1. So what we could do from here is create that same table. So x, y, 0, 1, 2, 3, 0, 1, 4, 9. Apply my h, which was negative 1. A is 1, so none of those y's are going to change. But k is plus 2. So all of my y values are going to go up 2. And then we plot our points the same way we've been plotting them. The y-intercept occurs when x is 0. The y-intercept occurs when x equals 0. So in this case, if I plug 0 in for x, I get that the y-intercept is at 3. I can see that both by plugging 0 in for x and solving for y. I can also see that on my graph. I can also see that in my table. So to ease the stress of graphing today, you're really just going to be converting. We're just going to be changing n from standard to vertex and vertex to standard. We'll go back again to graphing tomorrow, but that is the connection between standard and vertex with graphing. Let's do one more conversion. So let's convert once again. We're going to go from standard form to vertex form. So to go from standard to vertex, I need to know what is A and what is B. So A is 2 and B is 10. My H value is always going to equal the opposite of B divided by 2A. So in this case, negative 10 divided by 2 times 2. We get negative 10 over 4, which is the same as negative 5 over 2, which if you want to see it as a decimal, it's negative 2.5. I will keep it as negative 5 over 2. To find your K value, we plug that into the original problem. So negative 5 over 2 squared becomes 25 over 4. 2 times 25 over 4 becomes 12.5, or 25 over 2. Plus negative 50 over 2 plus 7, which 7 over 2 is 14. So 25 minus 50 is negative 25. Negative 25 plus 14 is negative 11. So then it says, what is the vertex form? So again, you're going to find H, you're going to find K, and then you're going to plug it all back in. So you get Y equals, A is always the same for both. So 2, X minus is always part of the problem, whatever your H is, squared, whatever your K is. You can clean up the minus a minus and make it a positive. You can also leave it as a minus the minus. So this is your final answer as to what is the equation from standard to vertex. The easier of the two is changing vertex to standard. So the easier of the two is changing vertex to standard. So that's what we're going to do on the back. How do you convert vertex form to standard form? Converting vertex to standard, we're going to follow our order of operations, which means we're going to start with FOIL. So that becomes y equals 3 x minus 3, x minus 3, minus 4. So anytime you have something squared, you have to FOIL, not just distribute the square, because then you lose the middle terms. So that's 3x squared minus 3x minus 3x plus 9 minus 4. So again, first outer, inner, last. Now distribute your 3 out in front. So once you've distributed, now you can find like terms. That's it. So like I said, converting from vertex to standard is pretty simple. Converting standard to vertex is a little bit more of a pain. So what you're going to do is practice both of those for homework tonight. The first couple are converting vertex to standard, standard to vertex. So again, the order of doing that is to first find your vertex and then to find the equation. I set them up for you to walk you through the process. So you have x equals h, plug h back in, and then plug it all in. So I kind of gave you space below each part to work it out.